So, hello friends, welcome to my YouTube channel. So today's topic is the schedulers. Okay, so schedulers. Okay, so there are around five types of schedulers. Okay, daemon set, the node affinity preferred, node affinity required, node selector YAML, and node selector and 10 tolerations. Okay, so first we will see the node daemon set. Okay. So what daemon set is? Okay, so daemon set, if you see this deployment, if you see this YAML file, okay, so it is almost same like deployment only. Okay, ignore this volume mount parts. Okay, it will be coming in the further sessions. But if you see the above part, okay, so it is looks like it is deployment file only. Okay, so it is daemon set is like deployment only, but there is no replica entry here. Okay, so if you see there is in the specification tab, there is no replica field is there, right? So this is the difference between the daemon set and the deployment. Okay, so so what daemon set does is, okay, it is create the um, it is create the pods on the available on the number of created nodes. Okay, so if you have the cluster and in that cluster you are having two nodes deployed. Okay, so let's say if you have uh, two nodes, right? This is the two nodes. Okay, so in your cluster, then if you run the daemon set YAML file, okay, so two pods will be deployed, one onto one onto this node and one onto this node. So it will deploy the number of nodes depending on the number of nodes. Okay, so uh, you you consider it as like number of nodes and there is number of pods. Each pod is deployed on each node. Okay, so if you create five nodes, then five uh, pods will be created and each deployed onto each node. Okay, so uh, this is the concept of the daemon set. Okay, so uh, how how daemon set create the multiple pod? Okay, it is based on the number of nodes. Okay, so where we can use this, right? So your ends, let's say multiple pods are running in different nodes. Okay, but the same application. Okay, so if you want to collect information from each pod, each node, okay, in that case we can use the daemon set. Okay, let's say in a monitoring agent, okay, we can run we can run daemon set. So in the monitoring agent, like you need to have the logs from all the pods, okay, on all the nodes. Okay, so this is the best this is the best uh, test case for the daemon set. Okay, so use case, let's say, है ना, this is the best use case for the daemon set to use it there. Okay, so let's start with the practical then. Okay, this is my repository. Okay, Kubernetes man, I will import it over here and clone. Okay, so before that we should have the git is running. Okay, yum install git hyphen y, and after installing the git we'll clone it from the here. This is my repository and we'll clone it from here. Okay, so just copy this git clone and oh sorry, I think this, oh sorry, I copied wrong thing. We need to take this https this URL. Okay, so git clone and this. Okay, so plus hyphen lrth cd. Where is the schedulers? Day 8, right? Day 8 schedules. Okay. Okay. So our first is demonstrate. Okay. So apply hyphen f demonstrate.ml, right? Okay. So pod is created. So how much number of pods will be created? We have already seen that there are two nodes are there, right? kubectl get nodes. So how much? One per each node, right? So two should be created. Let's check kubectl get pods. Okay, so you can see that two pods are running, right? And check whether these pods are created on the uh, respective nodes or not. Means describe kubectl describe pod. Means we are checking whether these nodes are created on two separate nodes, right? So this first pod is created, right? Nginx T5 and 6T. This is created on this node 2451. Okay, let's check the another one. First is created on 2451 and next is, let's check. Okay, so another is created on different node 5544, right? This is 5544 and this one is 2451, right? So both the are deployed on the separate nodes. Okay, so what if you have deleted this pod, right? So I meant to say, if I delete any pod, okay, so will it create again? Let's check, right? kubectl delete. Okay, we have deleted that pod. Now check. So what? So if you delete that pod, no, demonstrate will create it again, okay, and will deploy it on that node only. Okay, so it is just like a monitoring agent, okay, that will be help in the uh, those. Okay, so what if I have deleted the kubernetes one, sorry, demonstrate, right? So what I have deleted the file of the kubernetes, then those pod will be deleted, right? If you see kubectl get nodes, get pods now, then no resources found because you have deleted the daemon set, then respect to pod associated with that daemon set will also be deleted, right? So, okay, so this is about the daemon set. Okay, so the uh, next one is node selector. Okay, so if you see the node selector, okay, sorry, node. So if you have seen the node selector YAML file, okay, so this is just a pod. Okay, so this is just a pod till here, right? We have earlier seen this. This is the kind of the same pod. Okay, so what extra thing is here is this is the node selector tab, right? So node selector tab is there. Okay, so here node selector section is in the pod, right? Earlier we have seen this field in the service part. Okay, so in that case service was calling to the pod, right, by matching the labels. Okay, but here that section, that node selector section is in the pod. Okay, so here pod is calling something, means node. So we need to label the node here, right? Both ends. So we need to label the node. So both ends when labels match, then and then only that pod is scheduled onto that node. Okay, so here pod is calling to the node that I want to schedule on this node. So if you given this node selector as size equal to large label, no, so you have to decide on which node you want to schedule this pod. Okay, so this is in terms of pod. Pod is calling something on which node I need to deploy. Okay, so the use case is that whenever you want to deploy pod on the on specific node, okay, so that time you can uh, use this strategy of the scheduling, that is the node selector. Okay, so here is the label is the size large. Okay, so we need apply hyphen f node selector. Okay, so how many pods will be created? Only one, yes, because this is not a this is not a demo set, it is node selector. So one pod is created, but you see that this is pod is in pending. Why? Why this pod is in pending? Because there is no matching label of the pod with respect to the node, right? So we need to label the node that we have given in the pod, that is size equal to large. Okay, so we will just label the node now. Okay, copy this and okay, first get the node details also, right? We are just we require the node detail also. Okay, so this is the node on which we need to deploy, let's say. Okay, so change here the that node name. Okay, okay, so for this node we have marked this node as a size equal to large. Okay, so this label will be matching with this my app pod. Okay, in which we have given this pod as a size equal to large label. Execute it. Okay, so you can see that this node has been labeled, right? Now check the your uh, pod status. See, now it is turned to running state because it is scheduled on this particular node. Okay, you can cross check kubectl describe pod my app. Okay, so this pod will be scheduled on this 2451. Okay, just cross check. See, here you can see that this pod is scheduled on this particular node 2451, right? So this is about the node selector. Okay, so it will be used in where you want to schedule your nodes. No, so sorry, pods. Okay, so this is in terms of the pod. Okay, pod is deciding on which node I need to schedule. Okay, so this is about the selector. Okay, so just delete the pod what we have created node selector. Okay, so if you delete the file, no, then it will delete the pod also associated with this node selector kubectl get pods. Okay, so that pod is also deleted now. Okay, so the third we will move to the third. Okay, so what is the third scheduler? Let's check. Let's hyphen lrth. So third one is the node affinity. Okay, so node affinity, there is two types: node affinity preferred and node affinity required. So first we'll see the node affinity preferred. Okay, so if you see this YAML file of the node preferred, okay, so this is same like the pod only. Okay, but from here this affinity section. This is change. Okay, so this is the additional thing in terms of labeling of the pod. Okay, so preferred during scheduling, right? You can see here preferred during scheduling means at the time of schedule the pod in the nodes. Okay, so here you can give two different labels. Okay, means this is, if you see, this is like node selector only. Then what is the difference between this node selector and node affinity? Right? Here you can give the more labels, right? The preferred during scheduling means you can give the more level, right? This match expression tab you can give that key size. Okay, key size matches with medium and small. Okay, so you are giving here more labels. Okay, so you are having more precise control over your pod to schedule on the node. Okay, so preferred during scheduling means at the time of schedule the pod in the nodes. So here you can give the two different labels, right? Size equal to medium and size equal to small. Okay. If size equal to medium or small, it will deploy pod onto that node. Okay. So if you are, but if you label one node size equal to small and one node size equal to medium, right? So if you have given the any of the node, okay, the label as medium or small, it will deploy onto that node. Okay, whether you give small label to that node or medium label dot node. So either one it will match and it will deploy that port to the that particular node. Okay. Uh, but what if but what if you label the one node with the size equal to small and one node with equal to medium, then what will be scheduled? Okay, then it will see the weight. Okay, we have already given here the weight. Okay, so on which node the on which level the weight is more, that pod will be deployed on that node. Okay, so this is the node affinity concept. Okay, so apply hyphen f node affinity preferred. Okay, so check the status of the pods. Okay, so one pod is created. Okay, and it is running also. Okay, so why it should be running? Because we have already given the label in previous while we have given the label in the node affinity. Sorry, in the node selector, right? So just check whether that label is exist or not. Okay, kubectl get nodes hyphen o wide. Okay. So we have already given the label, right, in the particular node. So that is why it is match the label and it was the pod is running. Okay. So what we will do is we'll remove that label first now. So how to remove that label? Size equal to size minus. Okay. Okay. So we have unlabeled that node. Now check the status of the pod. Okay, because it is already it was already scheduled on that node. Okay, so it will be not be turning off its state, right? Because it is already scheduled. So you need to apply that node affinity preferred file again. Okay, so let's do that. kubectl delete hyphen f. Okay, now just check the pod. It will be no pods, right? No resources. Now check. Now apply that. Uh, Now apply the node affinity preferred YAML file. Okay. Now check the get pod status. Okay. So it is matching, right? Okay. So it is running because so now we have again run this node affinity preferred. So pod is created, right? But labels are not matching, right? We have already removed the label now, right? We have removed the label earlier we have given in the node selector, but here we have removed the label. So here the label is not matching, right? If you see nodes hyphen o wide, there is no label. Okay, there is no label for this node. Okay, so still that pod is get scheduled, right? On any of the node, right? So why this happens? Because you are giving your preference only. Okay, kubectl, you are giving your preference only in this scheduling. Node affinity preferred. Okay, node is sorry, pod is created, right? But labels are not matching, right? Still pod is running because this is preferred only. Here you are giving the preference only. It is not a mandatory case. It will schedule on any node. Okay, so this is the case where the in the concept of node definitive preferred, it is preferred. Okay, so now we'll move to the uh, another scheduling, that is node affinity required. Okay, so before that, delete this node affinity preferred. Okay, so we have deleted. Now let's see the status of the pod. Okay, it is also deleted. Okay, so we will move on to the next, that is node affinity required. Okay, so node affinity required. So this is node affinity required. Okay, this is also same like the pod. Okay, here we are giving the node affinity pod. It is required. Okay, required during scheduling. So this is the mandatory case. Okay, here you are giving the mandatory that you should have match the labels. Okay, match expression. So here we are giving the labels as key size operator, means operator in means it will check this operator size in medium or small. Okay, so this is the key value pair. Key is size and value is medium or small, and this operator checks the size in the values. Okay, so if your pod is having the label medium or small, then that pod will be deployed. Pod will be scheduled on that node. Okay, but if your node is not matching the not having the required label, so then in that case your pod will be not scheduled. Okay, so this is the main difference between the required during scheduling and preferred during scheduler. In earlier case, it was just the preferred case. Okay, if your labels are not matched, then and that case also be it will be scheduled. But here in the required, it is required. Okay, your pod should match the labels, and then only your pod will be scheduled on that particular node. Okay, so apply hyphen f node affinity required. Okay, so what will be the status of the pod now? In cases, it is in pending, right? Because labels is not matching. We have not given any label on that any of the node. Okay, this is the mandatory case. Okay, it is checking first if the labels are matched, then and then only it will schedule the pod onto that particular node. Okay, so let's apply the labels now and check whether that pod is scheduled onto that node. Okay, so size equal to, what was that command? Size equal to large, no? get, sorry, describe pod nginx test. This is my pod. Okay, so where is the node here? Here. See, this pod nginx test is deployed on this 2451, which we have given the label as size equal to small, and this size equal to small label matches with the uh, what we are given in this node affinity required YAML, right? Here we have already given the size equal to small label. Okay, so this is the concept of the uh, node affinity required. Okay, so delete that delete the label. Okay, size equal to large. Okay, we have unlabeled the node and delete the node affinity required also. Okay, kubectl delete. So deleted. Now check the status of the pods. It will also be deleted, right? So this is fresh case now. S- So now the last is 10-10 tolerations. Okay, this is the last one, 10-10 toleration. So what this 10-10 toleration means is, okay, so here tainting, okay, tainting the node means here we are giving the, okay, so this is the tolerations, okay, so this is the concept of the 10-10 toleration, okay, so better we will explain it into the paint, okay, so this is very confusing, okay, so if you have any, this is my pod, let's say, okay, this is my another pod, okay, and I am having, this is my node, okay, and this is my another node, okay, so if I tainted my node, okay, if I tainted my node, okay, tainted node, then only tolerate pod, okay, so pod which are marked as tolerated only, okay, they will be uh, able to deploy on this node, okay, so this can deploy onto this node, tolerated pod, and this can deploy also, okay, and this can also deploy onto normal node, okay, so this is my, let's say, normal node, okay, which is not tainted. So tolerated pod, okay, tolerated pod can deploy on any of the node, whether it on tainted node or normal node, okay. So control is given on the node, okay. Tainted node means if you have to, let's say, if you not tolerate, if you not tolerated pod, okay, then this is the normal pod, okay, so this is the normal pod, this will be not scheduled on this tainted node on any case because it is not tolerated one, okay, so the tainted node means here the concept is like if you have to maintenance your node, okay, if you have to maintenance your node, then you are restricting from scheduling the pods on this particular node because you are maintenance is going on to that node, okay. So those pod only which are marked as tolerated, those pod will be get deployed onto this tainted node, okay. Other normal pod will not be able to deploy on this tainted node, they have to deploy on this normal pod only. So tolerated pod can schedule on any node. Restrictions are given at the node level. Okay. So let's check now the with the help of the practical. Okay. So this is my YAML file of the ten ton toleration. So here we are giving the pod, okay, and we are giving the tolerations to the pod, that is key equal to app and value is equal to blue, okay, and effect is no schedule. So these are the labels, okay. Blue we are giving the app, okay. So kubectl apply hyphen f 10 toleration, okay. So okay, first, sorry, before this, we'll mark the label as uh, tolerated the pod, okay, so that we can see. Okay, delete this file, okay. So first we'll taint the node, okay. So how to taint the nodes, okay. So I must be having the syntax ready, node affinity, and node daemon set is done. So this is okay. So this is the syntax, okay. Size equal to large or R for node taint. Okay, so this is the command, no, taint nodes, okay. Okay, before I will taint the node, okay. So app equal to blue, okay. This app equal to blue label is matching with the pod, what we have seen in this file, no, taint and toleration. So I will copy the node name now. Let's say this one, okay. So I am tainting the one of the node, okay. My node has been tainted, okay. So check the status of the nodes. Open O wide. Okay, so I have tainted the this 2451 node. Okay, so this is node has been tainted. Okay, so now you can apply the file. Okay, so let's check whether any pod is running. Get pods. So no pod is running, right? So just apply this file now. kubectl apply have an app 10 toleration. Okay, so just check the pod status now. See, that pod is now running. Okay, so this pod is matches the label of the blue, right? This blue label is matching with the what we have, because this is the tolerated node we have given, and this node is sorry, this pod is should be running on this particular node. Okay, that the tainted node. So kubectl just check the whether it is deployed onto that node or not. Describe describe pod ngnx hyphen t. Okay, so check in the node section. See, this pod is deployed onto this 2451, which marked as a tainted one. Okay, so if you create other normal pod, okay, so we will see whether that pod is deployed onto that this node or not, right? Because that will be the normal pod. Okay, so we will run the replica set, okay, and check whether we can whether that node that pod is scheduled onto this or not, because this is the tented node now. That normal pod should not be run on this 2451. Okay, so where is my replica set? Worker node compounds. This one, right? So copy this file and run the rs.yaml. Okay, so I have run kubectl apply -f rs.yaml. So I have given the replica as a 3. Okay, so 3 pods will be created. Now just check the pods, kubectl get pods. Okay, see, this one was the earlier one. This the pod which was deployed onto the sorry, scheduled onto the uh, this tented node. Okay, but this should not be, because this is deployed as a normal pods. Okay, so this should not be deployed onto that tented node. Just check kubectl describe pod and check whether it is deployed onto that tented or not. Tented node. Kubectl describe pod. Okay, sorry. kubectl, there is a syntax error. So this check the node section of this pod where it is here. See, this node is not deployed onto the 51, right? Because this is the normal node. Okay, so this is not deployed on the 2451. So this is the concept of the tent and toleration. Okay, okay. So one more concept is there. Okay, so that is called. You see now my if pods. Okay, so there are 4 pods. Okay, so these three are normal pods, and this one is the tented, sorry, tolerated pod, which is scheduled on the tented node. Okay, so there is a, if you see the command of the this tented, what we have used for the tented node. Okay, so in that you have seen this no schedule. Okay, no schedule. Okay, so if my pods are running on untented node, okay, this web rs no pods, okay, after that if I apply or enable the tent for that node, what is the status of my running pods? Still running. Okay, without any impact because of no schedule. So if I change the label now of this label, no. So if my pods are running on untended nodes, after that, if I apply or enable tent for that node, okay, what will be the status of my running pods? Still running, because without any impact, because of no schedule, because no schedule. Okay, so no schedule, it will be run. Okay, we are not giving any no execute conditioning here. Okay, but if you given the here the no execute, okay, then what happens?